Hello, today we're going to discuss flame rectification. In the past we used products like thermocouples and power pile generators to use heat to produce a voltage that we utilized in our circuitry to hold gas valves and operate circuits. When we went to solid state ignition systems, we actually changed that design and we went with an entirely different process that we really weren't very well educated on when that shift happened. So when we went to flame rectification on hot surface ignition and direct spark ignition systems, we completely had to relook at how we're testing for flame verification. So before we used heat to generate voltage through a device, and some, and actually probably many technicians in the field believe that we still utilize that process with a flame sensor. In actuality, it's not a sensor at all. It is a flame rod, which is simply a piece of stainless steel that is insulated by a portion of ceramic. And we take our control board and we now generate voltage from our control board. Typically it is between 40 and 80 volts AC, and we send that voltage into the flame rod, and as that voltage finds its way to ground, it passes through the carbon molecules that is in our fire, and as it's doing that, we generate a load on those carbon molecules, and because it doesn't have a direct path to ground, we actually skip around and chop off part of the AC sine wave, so we get a rectified signal. So it looks more like a DC signal than an AC. But it actually started out as an AC voltage. So when we take our meter and we separate our flame sense wire from our flame rod, we can actually read current that is being generated, and it's read in a microamp version, a microamp DC. So what we are actually reading is that AC that is being rectified on its way to ground, and we are reading the load now that is happening on those carbon molecules. So it's actually not a process of heat anymore, it is a change of state of voltage.